Jai Hind to all. My name is Divya Sharma. Now today's my video lecture is on electric flux density and Gauss law. Now first, electric flux density. Let us define a new vector D that relates the medium and the electric field as D is equal to epsilon electric field intensity. That is, D represents electric flux density, that is equal to what? Epsilon, and this is your electric field intensity. Okay, so and flux is equal to what? Closed integration this phi, or you can say this D differential flux, and closed in closed integral, that is D dot ds. This is the for the surface. Now electric flux density, this is already we have done. D is equal to epsilon electric field intensity. Now units for epsilon is farad per meter, and electric field intensity, its units are volt per meter. Now this is equal to what? Means you have to find out units for D, means electric flux density, that is equal to C coulomb upon meter square. Now you can see, as you all know, Q is equal to CV. So unit for C is equal to farad and unit of V is V, volt. So for charge, means you have to find out unit for Q charge, that is equal to coulomb. So put the value here, F dot V, that is equal to C, and M into M, that is M square. So this is the limit for electric flux density is equal to coulomb per meter square. Now D is equal to epsilon electric field intensity, that is represented as E. Now its unit matches with the surface charge density. Now what do you mean by electric flux? Electric flux is a measure of electric field lines closing an open surface perpendicularly. Let it be there is a point, means here is a charge Q and these are your electric field lines and this is your open surface. So these electric lines are perpendicular to this surface, that is electric field line. Electric field is represented by E vector in bracket R. Now electric flux closing an open surface. Now electric flux is represented as this is equal to double integration and D dot ds. So this is electric flux density. Ds is the surface for the Gaussian surface. Now here its limits are, ds limits are meter square and D already we have done, its units are coulomb per meter square. So finally electric flux units are coulomb. Now here, if you all know electric flux density is equal to double integration D dot ds cos theta. Now here if D is uniform, it means you can take D common from, means outside from this integration. So this is D in double integration ds. Now here cos theta. So that is equal to what? Cos theta is here. So D cos theta. Now here you will get here D as cos theta. If D is non-uniform, it means here electric flux density is equal to double integration D dot ds cos theta. If it is uniform, then you can take D outside from this integration. If it is non-uniform, then you can take D in the integration, inside the integration. Now here next is net outward electric flux closing a closed surface and closing a volume. Let it be this is a volume, means this is a cube in form of volume. Now here is a point Q charge, here is a point and its charge is represented as Q. So electric field lines are represented by E vector in bracket R. Now this is a enclosing a volume. So electric flux intensity is equal to this is electric flux is equal to double integration D dot ds. So this is the formula for closing a volume, means you have an enclosed a volume. Now Gauss law. Now here it means what? Let it be there is a cube and there are some inside charges and outside charges. Let it be there inside charges are Q1, Q2 and the third one is Q3. And electric field intensity due to these charges Q1, Q2, Q3 are represented as E1, E2, E3, and outside charges are E4 and E5. So here E4, due to Q4, electric field intensity is represented as E4, and due to charge Q5, electric field intensity is represented as E5. So inside charges are Q1, Q2 and Q3. So and outside charges are Q4 and Q5. So here you can apply this formula, means according to Gauss law, closed line integral, closed surface integral, that is equal to what? D dot ds. Here D dot ds due to all charges inside and or outside the volume, that is equal to what? Q enclosed. Q enclosed means you have to write down inside charges, means those charges which are present inside the volume. So you can write down here Q enclosed. So and inside charges are Q1 plus Q2, this is minus Q3. So write down here Q1 plus Q2 minus Q3. So this is the Q enclosed. So Gauss law is also Maxwell equation, and according to Gauss law, its full name is Carl Friedrich Gauss. The total electric flux, this is the representation of flux, though any closed surface is equal to the total charge enclosed by the surface. Okay. Now flux is equal to Q enclosed. Now here you all know flux is equal to what? Closed integration differential flux is equal to what? D closed line integral or closed surface D dot ds. Okay. Now and you all know Q enclosed is equal to what? Integration rho v dv. So put these values in this equation and you will get here closed integration D dot ds is equal to rho v dv. So by using these equation and this equation, means you can put this equation and this equation and this in this equation and you will get this equation. Now from divergence theorem, as already we have done in the previous video lectures, that closed integration D dot ds is equal to integration del dot d dv. So this is equal to this one, and put this equation, means put here the value of D dot ds from this equation and you will get finally del dot d is equal to rho v. So this is the final term. This is the first of the four Maxwell equation. So that is rho v is equal to del dot d. So this is the Gauss law. Now del dot d is equal to rho v. If rho v is constant, so uniform charge density. But if rho v is a function of x, y, z, so you can say non-uniform charge density. Now the third case is if rho v is a function of x, y, z, but you have some values, let it be a, b, c. So put these values in this function of x, y, z and you will get here del dot d is equal to 0. Okay. So x, y, z means you can put the values. If you have some given points, you can put in this function of x, y, z, and if you can put and your divergence del dot d is equal to 0, then point is source free. Let it be you have this point Q, this is electric field intensity, electric field lines, and you have some surface. Now see, point is source free means let it be you have point here on this electric field line. Let it be this is a point and this is not a source. So you can say this P point is source free and Q is the source here in this figure. Now Gauss law, first a continuous charge distribution has rectangular symmetry if it depends only on x or y or z, and cylindrical symmetry if it depends only on rho, and spherical symmetry if it depends only on r or independent of theta and phi. Now the second point is Gauss law is also valid for asymmetric charge distribution. However, you can't apply Gauss law to determine electric field intensity or electric flux density. In such situations, apply Coulomb's law. Now the third point is Gaussian surface is chosen such that D is normal or tangential to the surface. When D is normal to the surface, then D dot ds is equal to D, and for tangential D we will get D dot ds is equal to 0. So these are the 3 points you have to consider in case of Gauss law. Now case 1, let it be you have a point charge. Let us consider this is a cube and some point charges, some charges are inside the volume or inside the cube and some charges are outside the cube. So inside charges are q1 and minus q2 and outside charges are q3 and q4. So find out here Gauss, according to Gauss law, you all know close integration d dot ds is equal to charge enclosed. So charge enclosed means you have to consider the charges who are present inside the volume, and inside volume charges are q1 and minus q2. So q enclosed equal to what? q1 minus q2 and its unit is coulomb. So this is the first case, means this is the first case, that is point charge. Now second case, let it be you have a cube and you have a line, means you have a line charge in this cube and its cube sides are represented by A. Now let it be this line is inside this cube and this line is outside this cube, this one and this one. Its charge density is lambda. Inside line charge density is lambda, outside charge density is minus lambda 1 and minus lambda 2. Now find out here, according to Gauss law, find out here d dot ds. So closed integration d dot ds is equal to q enclosed, means you have to consider the inside line charge. So here that is integration rho dl. So write down here rho l is equal to what? Rho l is the line charge, means charge distribution, that is represented as lambda, and dl is, so you can consider dl is equal to A. So lambda A is the q enclosed inside this cube. So its unit is coulomb. So this is the case for line charge. Now the third case is for surface charge. Now let us consider there is a cube inside this surface and surface is also a Gaussian surface. So here its charge density is rho and outside there are some surfaces, its charge density as are rho 1 and minus rho 2. So according to Gauss law, again closed integration d dot ds is equal to q enclosed. So here this is the case of surface charge, and surface charge density is equal to what? Rho into ds. Okay, now put the value of, means you can, this is your you can take common rho integration ds. So surface, you can find out surface according to this figure, you will get here a square. So this is rho sigma dot a square coulomb. So this is the q enclosed inside this cube, or you can say close integration d dot ds is equal to sigma dot a square coulomb. Now the fourth case is volume charge. Now here this is a volume and inside some volume is there present in this Gaussian surface. Its charge density is rho v and its volume is represented by v. Now some cubes, some closed cubes are outside this volume also. Its charge density is minus rho v1 and second charge density is minus rho v2. Now here according to Gauss law, you have to find out closed integration d dot ds is equal to q enclosed, and you all know the formula for this q enclosed for volume is in the triple integration rho v dv. So rho v you can take common outside this integration and put the value of dv, and dv is equal to v. So your integration, closed integration d dot ds is equal to rho v dot v coulomb. Now model of Gauss law. Now first is point charge. So this is closed integration d dot ds, algebraic sum of charges, that is q. Let us consider there are I charges inside the volume, so it is represented as I and qi. So this is for in the case of point charge. Now line charge, closed integration d dot ds is equal to integration rho l dl. Now the third case, surface charge. Now in this case, integration, closed integration d dot ds is equal to double integration rho s ds. Now the fourth case is volume charge. So double integration d dot ds is equal to triple integration rho v dv. So these are all four cases are inside the volume or inside the surface or inside the line charge. Now here application of Gauss law. Now closed line integration means closed integration d dot ds is equal to q enclosed. Now if you are considering the case of line charge, so consider here rho l dl. If you are considering the case of surface, so integration rho s ds, and if you are considering the case of volume charge, so here integration rho v dv. So in which charge is present? So inside the charge means the charges which are enclosed in this surface, and ds is represented as Gaussian surface, and Gaussian surface may be imaginary or closed or symmetrical surface enclosing a volume. Volume is should be hollow volume. So now here let us consider a question. Let us consider there are three charges, first, second, third. First charge is of 2 coulomb and its coordinates are 4, 8, 3. Now here this is x is equal to 4, y is equal to 8 and z is equal to 3. Now the second charge is minus 12 coulomb and these are the coordinates of second charge, minus 4, 0 and 2 are present inside the space. You have to check these charges are inside this space or outside this space. Now according to these coordinates you can check these are outside or inside the space. Now here the third charge is k 8 coulomb. Its coordinates are means x is equal to 2, y is equal to minus 1 and z is equal to 3. So calculate net outward flux through a closed surface minus 5 to 5, and you have x, y, z means x, y, z ranges from minus 5 to 5. Now here you have to check these charges are inside or outside the volume or surface. Now here how you can check? Now here you can check x, y, z ranges from minus 5 to 5. So this is the value of x. So at comes x equal to 4 comes in the category of minus 5 to 5. Yes. Now for y 8 is not lies in between minus 5 to 5. It means it is outside the surface. Okay. 3 you can check, but it is by using this y is equal to 8 you can check this is outside the surface. Now here for the second charge minus 12 coulomb, x is equal to minus 4, x is equal to minus 4 comes in the range of minus 5 to 5, 0 comes in the range of minus 5 to 5 and 2 it comes in the range of minus 5 to 5, and range is for x, y, z and you have to check x, y, z. So all these three coordinates are comes inside this range. So you can say this charge minus 12c comes inside the surface. Now the third charge, that is 8 coulomb. So here its coordinates are 2, minus 1 and 3. So x is equal to 2. So you can check x is equal to 2 comes in the range of minus 5 to 5. Minus 1 it comes in the range of minus 5 to 5 and z is equal to 3 it comes in the range of minus 5 to 5. So you can say second and third come inside the surface or inside this space and the first one is outside this space. Now according to Gauss law, how you can write down? Closed integration d dot ds is equal to q enclosed, means you have to consider inside charges only. So that is equal to what? Minus 12 coulomb plus 8 coulomb, that is equal to minus 4 coulomb. This is the answer. Now let us take another example. Again 3 charges are there. First is 2 coulomb, second is 8 coulomb and the third one is minus 12 coulomb. Now its coordinates are 483. Now 8 coulomb charges coordinates are 2, -1, 3, -12c coordinate -12c, this is the third charge, its coordinates are -401. Now calculate net outward flux though a sphere of radius r is equal to 6 and center is at the origin. So let it be, there is a sphere, its origin is 0, 0, 0, its radius is 6. Now how you can find out? First find out d1, that is equal to what? d1 is equal to under root 4 square plus 8 square plus 6 square, that is less than 6. So it is outside, means this distance is outside this sphere. Now check for the second charge, d2 is equal to what? d2 is equal to under root 2 square plus -1 square plus 3 square, it means you will get here the value that is less than 6. Less than 6 means inside the sphere. Now for the third charge d3, you can find out that is equal to what? Under root -4 square plus 0 square plus 1 square, its value is also less than 6. So it comes in the category inside the sphere. Now here these two charges are inside this sphere and this one is outside this sphere. So according to Gauss law, closed integration d dot ds is equal to q enclosed. So here again you have to consider inside charges. So inside distance is d2 is less than 6 and d3 is less than 6. So consider its charges are 8 coulomb and -12 coulomb. So here 8 minus 12 is equal to -4 coulomb. So this is the answer, means this is the net outward flux though a sphere of radius 6 and center is at the origin. Now let us take another example. A line charge with lambda is equal to 10 nanocoulomb per meter is present, x is equal to 2, y is equal to 4. Calculate net outward flux though cube x, y, z ranges from -5 to 5. Let us consider a cube. Here is a line charge, its coordinates are, means this is your cube, right, and its coordinates are x lies from -5 to 5. So write down here x lies from -5 to 5, y coordinates are -5 to 5 and z coordinates are -5 to 5. And line, this line's coordinates are x is equal to 2 and y is equal to 4. X is equal to 2 means x ranges from -5 to 5, it means it comes inside this volume, and y is equal to 4 means it ranges from -5 to 5, it is also comes inside the this cube, right. So its line charge coordinates are x equal to 2 and y is equal to 4, means these line charges, means this line charge is inside the cube. Now this is the line charge on the z axis. So z axis its range is -5 to 5. Now according to Gauss law, in closed integration d dot ds is equal to integration rho l dl. Now rho l means charge density for this volume is equal to what? 10 nanocoulomb per meter. Now in integration dl is equal to what? dl means you have to find out from -5 to 5. So put these values and you will get the result 10 into 10, that is equal to 100 nanocoulomb. So these are the examples of Gauss law. Now thank you.